Hello everyone, welcome back to today's stream. Yep, we're gonna continue with this TIS-100. I managed to figure out how to solve the Signal Multiplexer level already. So that's what we're gonna do now. We're gonna solve this. I tried it. I think it was easier than I thought. Okay, but yeah, let's go and do that. Yeah. So I'm live on 3 platforms again. Yep. Let's just go in and do it. So first thing I'm gonna go in. Yeah. As you can see, this mess of code. I'm gonna really now just delete all of it first. No, we're not gonna do any of this anymore. These two will remain. These two remain. This is no longer relevant. This is no longer relevant. I'll remove all of this as well, and this. Okay. Now, the idea is this. Whatever that comes into S, okay, the S basically influences everything else. So, in a way, S, or in S here, I need it to tell the other two, in B, in A, the 2 boxes beside here, whether to allow whatever that comes in from above it through or not. So basically the top column, the top row should be a sort of like a filter. It should filter out whatever that comes in. And then the middle row here, just add whatever that comes through. So here will be very simple, just add it. And then finally it just outputs whatever the bottom. So the idea is make it simple. Let's just, the filtering is done on the top level, and then the middle adds up whatever that comes in from the top, and output. Yeah, basically output just outputs. So let's do that. Okay, so first thing, of course, I will need to deal with in S, because that's where your enable pin is enabled. Basically, S is a selector. It selects which one you want as the input this time. So first thing we're gonna do is we're gonna, of course, create a label for it. So I'm gonna call this S for start. First thing I want to do is take whatever is coming in from the top, move up, and then I want to store this into ACC. Obviously, because I want ACC to have the, I need to do the measurement, the calculation from it. Next, what's in ACC? Move, jump. So we need to actually do 2 different things here. We need to check whether it is. As you can see from the side here, it's written here. Write in A when in.s is -1. So if it's less than 1. And then when it's more than 1. So we need to actually now see what value is in here, the ACC, and then determine whether I want to enable this side or enable this side. The idea here is, if we go back and see the opcodes available, we need to check, is it more than 0, less than 0, or is equal to 0. 3 things. So I'm gonna do one for more than, one for less than. And then if it is 0, then obviously we don't have to check that anymore, because we know if it's not more than, it's not less than, it is obviously 0. So, oh wait, what was it? So we're gonna do less than first, because we are talking about this -1 here. Okay, so jump less than 0. This one, JLZ. JLZ. And then of course we need to put a name for it. I'll create one. This. I'll just call it N. Yeah, I'll create that. Then another one, JGZ, yeah, greater than 0. JGZ P. So what does N and P stand for? N in this P here in this case basically just stands for negative and positive. Okay, now if it is not negative, not positive, means 0. So what happens if it is 0? Then I want A and B. I want both of them. So what I should do is move 1 to the left. And then again, move 1 to the right. So what I'm doing here is basically I'm saying, let both of them through. You'll see why I do the code for that. Yep. Then here I will do JMP S. So basically, jump back to start that this is done. Now, down here, I need to do for n. What is n here? N means it is negative. If it's negative, do what? Well, then I need to move. If it is negative, I want int a. Means I want the left hand side to be enabled. Move 1 to the left. And then I want to disable the right hand side. So move 0 to the right. So that's done for n. And then lastly, of course, don't forget this. Jump back to start. If I don't jump back to start, it will continue running the code below it. And then lastly, P, if it is positive, then move 0 to the left, because yeah, now I want to disable A and enable B. Then move 1 to the right. And lastly, of course, jump back to S, JMPS. Hey! Now, what do I do with the signals coming in? Obviously, I will need to do another checking on the left and the right hand side to see whether I'm enabled or not. If it's enabled, then I bring the value down. If not, then output a 0. Let's do that. So here what we'll do is move. I'm not going to bother the value coming in from up first, so I'm going to care about the values coming in from the right hand side. Move right to ACC. Obviously, this is the starting point again, so this is S, I'll put that. Move right to ACC. Then after that, I want to check whether it's 1 or 0, so jump. If it is 0, meaning I want to just send a 0 down. Jump greater than 0. So I will say EN, means enabled. If this is enabled, then I will have to jump. Okay, that one I'll create it after this. Jump greater than 0, or else, what do I do? If it is not enabled, then I will move up to nil. Basically, I don't care about the value of what is coming from up already. I just take it and throw it away. Then move 0 down. So basically, I throw away the value of up. Instead, I'm sending down 0. So that whatever that's coming in from int b added with 0 is basically int b. Because anything added with 0 is just basically that number itself. And then, of course, I need to jump back to start. So JMPS. Now I need to create a function for en, or the label. So what will en do? So if it is enabled, then I will have to take the value that's coming from up. Move up, down. And then, after I do that, JMPS. So basically jump back to start. And I will just duplicate whatever that's here onto here. Basically these two sides have nearly the same code. It's just that instead of move right, I'll be moving left now here. Left to ACC, so basically coming from this way in here. Yep. And then, okay, now what happens here then? Obviously, down here now, we need to take the two values coming here and here. Wait, why is this move up down? This is move up and towards the left. So this move it to right this side, let's move it from here to here, to the left. Okay. Move. I'll take whatever that's coming in from the left hand side and move it to ACC. So the value that comes in from here goes into ACC, and then I'm gonna add whatever that value is with whatever's coming in from the right. So add it with right, then move ACC down. So I do not need even other labels here already, because that's all it does. Take whatever's coming from the left, go to ACC, add it with whatever's coming from the right hand side, and move the answer down. And lastly here, move up, down. And that's about it. That would solve this problem. Okay, let's just run it and see. Yep, as you can see, all the answers are coming in correct. Awesome. And there we go. We solved it with a total... Okay, actually, this isn't a very efficient program. We have 32 instructions. We could have made it better, but it works. So we're only using 7 nodes. The best, I think, is about 5, I think. Number of cycles, 312. Most people got it in center here. Well, it can be made more efficient, but doesn't matter for me at the moment. It works. My main idea is get it working first. Probably come back to it some other day to make it better. Yeah. So yes, this works. Go to the next one. Okay, next we are doing sequence generator. Okay, create a new program. Sequences are 0 terminated. Read values from int A and int B. Write the lesser value to out. Write the greater value to out. Write 0 to end the sequence. Oh, okay. So, as you can see, the inputs coming in is basically a 46 and 71. Okay, so what happens here is I want to take the value 46 here coming in, output that first. Then I take the output from B and send that out. Then end it with 0. I repeat that again and again. So for every diff 2 in A and B, I have to send in A, then in B, then 0. Then repeat. In A, in B, 0. Okay. Let's figure out how to do this now. Okay. Take the value of A. Right? Oh! Write the lesser value to out. So it's not I take A then B. I have to take which one is smaller. So I have to compare and check A and B, which is smaller than which. Ah, okay. In a way, if you think of this, how it works is you are checking now, you're comparing the difference between the two. How are you going to do that? You need to turn it. Yeah. Idea here is you minus off A and B. So you take A minus B, and then you see whether it's negative or positive. Okay. Give me a moment. I need to think of what's the best solution for this. just take the values first, A and B. We will need, I'm probably going to do the comparison here. I'm going to compare A and B, the values here. So, okay, let's try that and see first. We will also need to store the value somewhere. This requires a bit of thinking. Okay, let's just try it and see first. Let's move up, and then let's move it to the right. So that way, you know, we have something we can compare it, okay? And then here, I'm gonna move up to ACC. So basically, I'm moving in ACC so that I get something in there first. Now I have a second problem. With this move into ACC, I would probably need to back up this value. So the idea here is I have A and B. I have to find out which is bigger than which. So I probably have to back up the value of ACC as well. I need to copy it to back because the moment I do any comparison between the two, the value in ACC would have been overwritten. So the idea here is I need to... One second, let me get the documentation out. Documentation. Okay, here we go. So the only way I can manipulate with the back register is to actually either swap it, or I can save. Save means copy the value of ACC into back. Okay, so that's what I'm gonna probably do here at the moment. I'm gonna save, copy whatever that's in ACC into the backup memory. Next, what I'm gonna do, now what I need to do is compare it with the value that's coming from int A. But I have a problem. The moment I do that, I'll lose the original value in int A as well. In A, yeah. So here, I probably need it to send it twice. What I'm gonna do is move up into ACC, move ACC to the right, and then once it does its calculation, I have to send the value of ACC to right again. This is trial and error. Let's go try this and see how it works. I haven't actually tried this level and completed it. Yeah, we'll see how this goes. Yep. Okay. We move it to the right. And then... So we gotta subtract. So let's see, yeah. Subtract, let's see, I'll open this. Subtract source from ACC. From ACC means I take ACC and minus right. Sub. Oh, sorry, not right. This is coming from the left. So I'm looking at now the value that's coming in from the left and subtracting. Okay, let's just check if that's really the case, huh? So 71 and 46. So I take whatever's coming from up there, 71 and 46. Okay, 71 goes into ACC. Then I take that 46 that's coming in from this side, move it this way. Step, 46 comes in here. and I subtract this with the left one, I get 25. So it means 71, which is B, went into ACC, minus 46. Answer 25 comes back here. Okay, okay. So that way I know B is bigger than A. So I will say jump. Oh, right. If I'm doing this, I need to make a label first. So S start. Oops. And then I need to jump greater than 0. And I'm gonna call it B, meaning that B is bigger than A. So I'm gonna call it B. Okay? So if B is bigger, then if B is smaller, so greater than 0. So now what I'm dealing here is if B is smaller, then I'm gonna do is move right down. Yeah. So move whatever's coming from the right down. And then sorry, not right. This is left again. So take whatever that's coming from the left to move it down. And then jump. Oh. Then I still need to move whatever's coming from the backup in downwards. So move. Oh, I need to swap so that whatever that's in ACC comes back up. Either way, I still have to swap it. But I can't swap it before packing. So the jump needs to happen first. No, actually I can make a new label that everything will jump to at the end. JMP final. Jump to the final. So F will be for the final. So in the final, wait, no, because I have to change the order of it. No. Okay, okay. Let's swap the two positions. Then ACC down. Okay, okay. I'm not gonna jump to start first because now I figure out one more, which is I need to send a 0 to end the sequence. So I'm going to now create the B one first. B. I'm gonna move. So what I need to do in B is I need to swap first. SWP. And move ACC down. And then move left to the down. So basically it's the same thing, but only thing the order has been changed. Move left down. And then okay, here I'm gonna do F. So finally move 0 down. And then jump back JMP S. So both of these will have to go to final. So JMP F. Here I do not need to jump to final because this will just continue down here. And then it will just jump back to S again to restart it. So in a way, this should work. down. Oops. There's a dot, not a comma. And copy this. And down. Oh, and let's look at the debug log first. There's a story behind this. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one though. Never found out what whole deal was, and if it turns out to be something I wasn't supposed to have, I think I could get in trouble. Cleared a little space on the workbench and hooked it up. Still works. Beautiful. Yes, it's a beauty, this one. Well, if you think of the language it uses, kind of beauty. It's a very simple machine, actually, if you think of it. Okay, let's just step through this first, so we can see whether it actually works with the first two. Okay, let's go to the first step. Whatever's coming in from up. Okay, 46 and 31. 46 is now in ACC. 21 is in ACC. Step through. Okay, now that 46 is coming in here now. I am now subtracting with left. Step. I get 25. Okay, so this is greater than 0, so it should jump to B. Step. Comes here. Swap. So this 71 should come back up here. Yep, 71 is up here now. Move ACC down. Step. Then one coming down. Good. Wait a second. Oh. Oh, the smaller number should come out first. Yeah, it should be 46 first. Oh, okay. So I can do... Yeah, okay. I'll just move this up. And the other one, I just change the position of it. Okay, this one. And then I'll change the position of this one. So this goes away. Comes here. There. Okay, this should be okay. Let's try that again. Step through. Go. Okay. 46 comes down first. Good. That's working. Next. Okay. Swap the positions of the two. So if anyone goes up there. And then I take ACC and move it down. Okay, 71 comes down next. Then I move a 0 down. Good. So 71 and 0. That works. Good. Now next is 29. So 29. 29. Negative 42. So 29 goes first. Great. Then I take where it's coming from the left. Move it down. So 71 is second. Awesome. Seems to be working. I think this program works. Let's run it. Oh, it is working. Awesome. Yeah, the answers are all correct. Oh, nice. I got 18 instruction counts, 18 instructions, 4 nodes, just nice. This is like where everyone is. And cycle counts. Okay, my cycle counts are a bit high, but oh well, you can't have the best of everything. And this works, so it's okay. What segment is? Okay, let's go for the next one. Sequence counter. Okay, let's try this. Sequences are 0 terminated. Read a sequence from in, write the sum to out s, write the length to out L. Oh, okay, so I have to find out when it reaches 0. If it doesn't reach 0, I have to keep adding them until I get a 0. This is basically like this is a loop. I'm going to do a loop here now. If it is not 0, continue doing the loop. Okay. So in a way, I need another memory here. I need another memory to store this. So I need 2 memories to be used. Go through and see. Let's see the debug log. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. Feel like I'm learning about the people behind this and the design decisions. Thoughts that went into figuring out how things should work. Those people feel very close to me now. I wonder who's this she the person is talking about. So yeah, the first sequence is 1 item, which is less than 35. Second sequence is basically you add up the 62, 51, 81, 54, 12, you get 260. And that's 5 items there. Okay. This is basically a while loop. While it is not 0, continue running this code. Yeah, it's a while loop. Okay, let's do it. Okay. So I'm gonna take the input from up, move up to ACC. Obviously this needs to go into ACC because I need to check if it is 0. Jump. Oh yes, this needs to go all into our table. Jump. Not equal to 0. Are there negative numbers? I don't see any negative numbers, but in case there's any negative numbers, I'm just gonna use jump not equal to 0. JNZ. So I'm gonna call it E, means end. I'm just gonna create it first, probably. Right about here. E. So empty, leave it empty. Okay. If it is 0, do something else. If it is not 0, I am probably going to store the sequence counter here. So move one. So basically I want this sequence counter to keep adding up numbers coming in. So move 1 to the right. Okay. And then I need to add it to the total. So I will need another place to store the total. I can use this one here to store the total. And the total goes down. Yeah, I can do that. So move the value that I get towards the left hand side. Let it go down. Good. In a way, this can do the counter, and this can be the memory that stores the counter. Here can be the actual place that sums it up. Or the sum code is here, but it just keeps throwing it in down here, and then this, once it gets 0, just outputs it. Let's see how it goes first. Okay, let's just try that. Okay. Now, I need a place to store the total because now ACC is being used to do checking. I can use back, probably. Up to ACC. Swap will come in very handy here. So back is 0 originally. If it is not 0, not a 0. Wouldn't it be jump if it is 0? Jump equals 0. Yeah, actually I should make it jump when it's equal to 0. Okay, jump when it's equal to 0. If it's not 0, I want to take the value, add it into back. So it should be stored in back. So I need to probably this is a problem. Because the moment I swap it, no longer the same value already. But I do think I need to keep this somewhere else. Probably on the left hand side. Because I can't add it here. Okay. Let's just make use of the left hand side to do that. Because the problem here really is I cannot swap it and then add it back because I have no place to store it. Or I got an idea. Move whatever that's coming in from the right back to right. in a way, I think whatever that comes in from the right hand side, just throw it back towards the right hand side. That way I can have it swap the two values. So I take ACC, move it to the right, swap, then add it back. I can do that. Let me try that and see. So I swap it. Wait, no, I need to move ACC to the left, and then move, swap between backup and ACC, then move back. What else coming from the... No, not move. Add. Left. To whatever that's inside ACC now. So it makes sense, right? So in a way, okay. You move whatever that's up into ACC. That's checking. Okay. If it is 0, jump here. But if it's not 0, okay, I want to move one to the right so that I can increase and a counter here. Here'll be a counter. Okay. Then move ACC to the left. So, and then whatever that's here, move it back. Swap it, then add whatever comes back from the left hand side. And then I need to swap it again. So that, yeah. Okay. Let's try this works. Okay, now if it is empty, or it ends, or if it is 0, what do I do now? If it is 0, then I will need to first take whatever value that's in back to swap it. And then after I swap it, I need to move ACC down. Yeah, move it down. And I will also move a 0 to the right hand side to make sure that the counter on the right hand side also gets cleared. So move 0. Actually, I got an idea. I moved this 0 to ACC because I needed to clear the back as well. Okay, and move ACC to the right, and then also save the value, so that now both ACC and back will be also 0. Yeah, okay, that makes sense. Then JMP back to start, so jump back to start. Yeah, I don't even need the JMP start there, but I will need it here. Yeah, I don't need JMP start here, because once it ends, it will go back to start. Okay, here, what I need to do now is take whatever's coming in from the left. So this I will need an S as well. Move left to ACC. So more or less it's the same thing. Then I need to check whether it's 0. It's the same code. The only difference is, rather than adding the actual value, I'll be adding 1. Okay, if it is 0, go to E. Okay, fine. Then move 1. No longer move 1 to the right. I don't even need this move ACC to the left anymore. Move 1 to the right. I don't need this anymore. Okay, but I do need to swap it. Then add 1. Start. Okay, this looks fine. Because I just add 1 and swap it back. Load it back. Okay, let's step through this. So I get 35 comes in. Okay, 35 comes in. Move up into ACC. I got 35 in ACC here. Now, is this 0? No, it's not 0. So, move 1 to the right. There you go. 1 comes in here. That 1 should go into ACC. There we go. Move ACC to the left. So, okay. 35 comes in here. I'm swapping now between them. So 0 becomes 1. Yep. I add 1 to it. Okay, that 35 comes back here as well. Swap. Add whatever's in left. 35, good. So I have 1 here now. Jump to S. That. Okay, good. So there's nothing here. Jump to S. Good. Then the next one comes in. 0. And it is 0. So I jump down to here. Swap between the two. 35 is not in ACC. I take the 35, move it down. Okay, yeah, well, okay, there's nothing accepted here, so let's just finish this part here then first. Move up, down. It's gonna be the same for here as well. Move up, down, move up, down, move up, down. So all this is the same. And then let's just jump through this. I got 35. 35 I know is working. Okay, move ACC down. 35 comes down here. Move 0 to ACC. Okay. Move ACC to the right. 0. Okay. It is 0. So, okay, now ACC and back is now both 0. It's been cleared. Good. So I swap here. Move ACC down. Okay. Oh, I need to remove this as well. I don't need this. Move 0 to ACC. Move ACC right. Save. No, okay. I'll get rid of this. And I probably want to change the position of this. Move ACC down. Then move 0 to right. Then move 0 to ACC here. Yeah, because I want this to start running before I care about clearing the rest. 0 ACC, okay. Do that again. Oh, where are we now? 62? Why are we doing 62 now? Oh, correct. Okay, 35 is coming down now, okay. Okay, 35, good. 1, okay. 1 should be coming down here. Yeah, okay. 62 gets accepted. I'm moving now ACC down, so I will have 1. Move 0 into ACC, okay. Okay, 1 came out here. Good. Yep, okay, good. That's working. Okay, good. See, it added another one, so ACC is now 2. I swap it back. We go back down here, yeah. Here it is. Jump S. Great, this is actually working. See, it's sending here. This is just pushing it back. 154. They currently have 113 now in the counter. 3, 194. Good, this is working. 248. Awesome. 4 now. 5. 460. Great. See, we got the answer here. Now next, 0 is gonna come in. Now it is 0. So, swap the 2. 460 comes up. Send this down. 460 goes down. Okay, move 0 to the right. Hit 0. Okay, clear the values. Great. There we go. So it's working. Can just run everything now. So the main core that's doing all the work is actually this one. And this seems to be working. Yeah, it is working. Working very well. Awesome. 28 instructions. Not the most efficient one. 7 nodes. Oh, there are people who've done with less. Actually, I got a feeling I got something I can do to improve this a bit. Like, because this one is not doing anything while it's waiting, so I can move this one up 1 level. Now this is like really small optimizations, but yeah, well, help a bit. So move the 0 to the right first. Let's just run this and see whether it helps anything. Apparently that apparently is a way to make this more efficient. I'm not going to care about the minor optimizations first. This helps a bit more. Doesn't seem much different, but no, well, okay, well, it works. Doesn't matter. Whole idea is to make sure it works. Okay, next one. What we're gonna do now is Signal Edge Detector. B. Read a value from in, compare value to previous value. Write 1 if changed by 10 or more. If not true, write 0 instead. First output is always 0. Read a value from in. Okay. Read a value from in. Compare value to previous value. So I need to store the previous value. Write 1 if changed by 10 or more. Or else write 0. Debug. Days and days and days. Cycles and cycles. Just one after another. Sick and tired of people who don't respect me. Time to pack it up. Interesting. Okay, read the value from in. Okay, of course I have to read it. So let's do that. Move up. Where am I gonna move it to? I'm gonna move it into ACC. Yeah, obviously. Okay. Now I need to store the current value as well. And I will also need to store the previous value. The previous value, I probably can use the left and right nodes again. Current value, previous value, something like that. So let's store the current value on the left hand side. Like just now, you know? Just move it back. Move right. Yeah, we'll have that here. Move right. Okay. Here. Am I going to do the same thing? Move left. Can do that. Can do that. Yeah, let's try that. This will be the one doing all the calculation again. So I will probably need S. Move up to ACC, then okay. This will be current value, previous value. Previous value would be 0. First value is always 0. Yeah, that's the issue here, because when I first start the program, there's no previous value. So I need to initialize it with the initial value. Probably need to do something like, so let's assume this is storing the previous value. So I'm going to say starting, move 0 to the right. L for loop. My loop will basically be move right, then jump, loop. So it's just gonna keep running this part here. Give me a second, I'll be back. Hello, I'm back. Yep. So, okay. I need to probably store the value better than this. Move right. So in a way, if I move right, whatever that's being stored is temporary stored. Previous value. Okay, never mind. Let's leave it as it is first. So I'm going to store the current value into left as well. So move ACC left. And while doing that, I would also need to now I need to compare the value. Okay, right one, if the value from the previous one has changed by more than 10. So how do I check if it's changed more than 10? I need to minus them off and then check if the value. So what I'm gonna do is probably take whatever the previous value minus the current value and then minus 10. So assuming that how it works, huh? And let's see, yeah. So assuming the previous value, okay, like for example, current value is 32, previous value is 0, so minus 0, and then I minus another 10. So that will give me a total of 22. So that way I can know that this is more than 10. Let's use the second scenario in that case then. Okay, so I have here in the second one 32, actually no, 30 minus 32 and minus 10, which will give me negative 2. 30 minus 32 is negative 2, minus another 10 is negative 12. That's what I'll get if I do that. The third one, I'm comparing next to, change by 10 or more. I will need to check if it is, because this one, since it's 2, yeah, I don't think I can. This requires a bit of thinking as well again. The same issue with the other one. I don't think I'll be able to solve this right now again because, yeah, like I said, it's a bit of thinking, and the logic is here. You just have to like think for the proper formula to use here. I might just end the stream here so that I can think of how to solve this first, and come back continuing tomorrow with solution. Something similar to this. This is the general idea is to make something like this, so that I can compare it. Less than 0, more than 0. Yeah. Yeah, I need to think of this first. So yeah, thanks for joining in. Hope you'll join in future streams. Thank you. Good night.